This is the Fields Homework Booklet, question number 11. Explain what is meant by the gravitational field strength at a point in a gravitational field. The definition of gravitational field strength is the force per unit mass. In brackets, I've just put the context, which is basically what was said in the question. Next, you're asked to state the standard international unit for gravitational field strength. Since this quantity is force per unit mass, we have got the units of newtons per kilogram. Please note that the value of meters per second squared, that unit, would not be accepted here. Although the acceleration due to gravity and the gravitational field strength have the same numerical value, they are different quantities, so you've got to pick newtons per kilogram as your unit here. Next, we consider two planets, P and Q. P has a mass m and a radius r, whereas Q has got a radius of 3r. You're told that the values of the gravitational field strengths at the surfaces of each planet are the same. Your first task is to find the mass of Q in terms of m, which was the mass of P. Thinking about this situation, if they are to have the same gravitational field strength at the surface, it follows that since Q has a larger radius, which would make the field strength decrease, it must also have a larger mass to combat that effect. So next, to find the exact extent to which the mass is larger. To achieve this, you need the equation for gravitational field strength at the surface of a large mass. So here we have that the gravitational field strength at the surface is the gravitational constant times the mass of the planet, in this case, divided by the radius squared. So stating that the two field strengths are equal, and then using symbols to denote the variables in each case, we can substitute into the general equation of gm divided by r squared. The g's will cancel, leaving us with the mass of P divided by r squared being equal to the mass of Q divided by 3r squared. Careful rearranging reveals the factor that we are looking for to be 9. So the mass of Q is 9 times greater than the mass of P. Finally, a graphical part to the question. So the graph shows the gravitational field strength above the surface of planet P and how that varies with the distance from the centre. So we have this curve here, which should follow an inverse square law. You are asked to draw onto the diagram how the gravitational field strength for Q varies over the range as you increase the distance from the surface. So you need to have the shape correct, but also, since there are 3 marks allocated here, the mark scheme is wanting some more detail and some accurate positioning of this line. So to achieve this, the first straightforward point to reveal is that at the surface of Q, which was a radius of 3r, it has got the same gravitational field strength as P at its surface, which was a radius of r. So starting with the same height on the graph, but corresponding to a different surface radius. Now you just want to make sure you're revealing you have grasped the inverse square law. So if we double the radius from 3r to 6r, we would expect the gravitational field strength to fall to a quarter of its original value. So just looking at the scale and counting squares, we go from the fourth square up to the first square up. Now we can repeat the same idea, so doubling from 6r to 12r, and once again falling from a whole square to a quarter of a square up.